Okay, so this is the first Twitch stream I am doing, so there might be some technical difficulties, but mostly I think we should be fine. So what I'm planning to do is doing collision detection through raycasting. So as you can see, we have this grid tile-based map here and a little guy running around, right? And yeah, this is supposed to be walkable. This is supposed to be sand. I just drew these myself, and this is supposed to be a wall, right? And of course the players should not be able to walk across a tile that has a wall in it. So, and the thing is, with like, I've done a grid-based game like this before, like multiple times, but actually I never did continuous motion, right? Where the player can actually walk around like this. What I did in the past is I had discrete motion. So the player, if you press the right key on the keyboard, for instance, the player is here, the player would just jump to this next tile. You press down, then there would be a check, is this tile free? If not, then nothing happens, right? But with continuous motion, this is a little bit different because we have to actually check each pixel or each current position of this player against like where the boundary is. Like these, you see these, maybe these are a little bit tiny on your screen. I hope they're like, you can see them, but these are like the red, this horizontal and vertical lines here that make the grid. You have to check if we cross at this vertical and horizontal grid lines. Do we cross actually into a tile that has a wall, a non-walkable area? And if so, we must not proceed. We have to stop the player at this position. And for now, yeah, I have like a small collision box here. But for now, I just want to check if the point is actually all right. Like if I can, I just want to use a point. So this collision box is actually just there to for nothing. It doesn't do anything. I plan to use it later, but for now, I just want to check if a point is able to make it across a grid line. And so what this does, if we maybe, let's see, so within a frame, the player might move so fast that before the frame, like before the logic actually is happening, the player is here, the user is playing the right key on the keyboard, and then like in the next iteration of the logic, of the game logic, the player would be actually here because the player is moving that fast. Like velocity vector is like making the player to move across here, and so collision detection test would actually fail. So the player would actually just loop, or not loop, just tunnel through this tile here. So the collision detection would actually not work properly. So we have to check if on the way from here to here there was an intersection with a non-walkable area. So before I actually start and implement this, I want to do like a debug line that I can just make a line, draw a line with the mouse, and then use this line to check if we hit something that is non-walkable. Okay, so let's do this first. So actually, maybe just have two vectors. We call this mouse A, and this is, we draw this in screen space, so I call it screen space. And actually maybe 2, and we have mouse B. Because we need two points to draw a line, right? So the first point is made by the user when he clicks once, that's mouse A, and then when he clicks again, mouse B, that is the end point of the line. I should say rather line segment, right? All right, and maybe I'm thinking how to implement this, excuse me, properly so I don't get crazy. Maybe just make an enum to track the state of the current mouse, because I want to be able to drag the line. So I click once, it sets the starting point of the line, and then I'm able to drag the mouse. And when I release the mouse button, then it keeps the line displayed. Call this maybe, I don't know, mouse state. And we maybe have mouse state clicked. So we have clicked once, mouse state drag or dragging, I don't know. It's when the user has clicked again and is just still pushing the mouse button and released. And oops, and this is of course like it's quite dirty. I plan to delete all this code again, but just for I want to visualize what is going on when I actually do implement raycasting, because otherwise I just will go crazy in the debugger and have to manually check every value that is tested, or yeah, I don't want to do that. I just want to have visual feedback. So let's see, with a mouse state. And the initial state, I guess, is released. And here I do some test mouse stuff. I just did this to check the platform thingy I used. Yeah, so if this key down and the left mouse button is pressed, so then I get the, I guess I get the current mouse position. Yes, I don't know, how did I call this? Position to D, I think. To D is, oops, mouse pos. So this is just part of the platform layer. This position to D just gives me the, it's just basically a vector, a vec2 I just defined earlier for the mouse positions for mouse A and mouse B. And actually, so if the mouse state, if we come from dragging, if we just drag the mouse and the key, sorry, actually this should be key up, right? So if the key was down and now it's up, then there are two possibilities from which state we come. The one is released. That is when the user is, that would mean the user is placing the first point of the line, and the other one is dragging, like the user just released from the second click. Then I would maybe say mouse state right, and that just means we go to, I'm not sure if this is actually good code or like maybe over complicated, but we will see. Not else, maybe an else if. mouse state, and this is yeah, this is actually released then, yeah. And then we just get mouse a screen space dot x. Or we just do this, and this is mouse pos x mouse pos dot y. So, and I think these are actually integers. Yes. So that's a little bit ugly, but to keep the compiler happy. Yeah, and there's actually, yeah, these are just floats. So this is a float vector, this is an integer vector. That's why we have to do it like this. And we also, I think we also have to get b, because if we come from released mode, then b is just set wherever a is. Otherwise, we would draw something weird. I think. Oh my god. Float mouse pos y. Yeah. Okay. Good. And then the other thing is, if the key is actually down, like the mouse key is key down, key left mouse button. So no, oops. So this means if the mouse state, actually what we have to do, we have to say the mouse state is clicked. Let me see. So if we come here, the mouse state is released. Yeah. That's the first time the user like clicks somewhere in the area of the window. Then the mouse state is clicked. So we have clicked. So if mouse state clicked, then we turn, yeah, and then the key is down. We come from mouse state is clicked, and the mouse state is mouse state drag. Right, yeah. So then right after that, if the mouse state drag, then we can say, yeah, then we get the position for the second, for the second position to D, for the second point of the line, position to D, mouse pos sp.get mouse, mouse pos, and we say mouse B screen space is float. Okay. Actually, why not just copy paste? Okay. And the mouse state actually doesn't change here, because the mouse state only should change when we release the mouse button again, which is here. When we come from drag, then it's released, and then actually nothing changes with our mouse A and mouse B. It only changes again when we come from released, which it is right now, and the mouse has been clicked. Then we set, we set these, like set a new A and new mouse B, which means we start to draw a new line. Yeah, I think this should work. Okay. And all we need to do now is, like, let's compile this. Okay. All we need to do now is draw the line. Let me see, where can we do that? I think I have to do it, yeah, I have to do it here, because here we set it to screen space. Graphics, draw line, and then we say mouse a screen space X, mouse a screen space Y, and we draw it towards mouse B, screen space X, mouse B, space Y, I don't know, width of 3.0 and a red line. Okay, let's see if this actually works. Okay. Yeah, so as you can see now, like, maybe I want to make this 4. If I click once, nothing really happens, but that sets mouse A and mouse B. That's why we actually don't see a line, because they're at the same point. Then I hold down the left mouse button and mouse B is updated. And when I release the mouse, then we go to released. And from released, if I click again, I can make this again, can make a new line. Okay, and now, as you can see, what I want to do is every time I hit like a vertical or a horizontal grid line, I want to know, and I want to know the exact coordinate position. Yeah, that's actually all I want to do. I want to know at which world coordinate I hit the vertical line and or horizontal line every time I cross one of these lines. And I just said world position, right? So maybe I should explain that. So as you can see, we have here screen space X and Y, and that's just the mouse position. And if I go to the top left corner, this goes to 0, 0, or almost 0, 0. I'm not quite able to hit that. And to the right bottom, it's like almost HD. 1920 by 1080, right? But the world space is different. So I define the world space that the top left corner is 0, 0. And so each tile is 32 by 32 units. So if I go here, it's at the X, it's 32. And if I go down here, it's 32, 32. So I have 5 by 5 tiles. So what is this? 160 by 160. Yeah. So if I zoom out a little bit, you can see like the screen space position is, of course, everything is changing. But if I go here to the upper left, like it's still 0, 0, right? But the screen space position of the mouse cursor is not. All right. Okay. So, but in order to actually do the collision, like the collision detection in world space, we have to, I think, yeah, we have to convert the screen space mouse position of the line, like mouse A, these points, the start and end point of the line segment. We have to convert them back to world space, so we can actually do collision detection or the raycasting for once. I have already a function for that. Let me see. We call these back to mouse a world space, maybe. And we say, I think I call this screen space to world space, yes. Okay, oh, so many parameters. Screen X, screen Y. So is this just 0, 0, I guess? Yeah, it's, I think, I don't remember how I actually programmed this. So, okay. Yeah, So we take the point, we go from we go from screen space back to the, so this is actually just the last, if you know OpenGL or any other graphics API, this is the last transformation is the window transformation, or it has other names too, which goes from normalized device coordinates to the actual screen coordinates of the display. And this is just reversing this process. So we go from the screen coordinates back, and the funny thing is here, I don't even use screen X and screen Y. So I'm always assuming this calculation, the fact that I'm not using them like screen X and screen Y here, tells me that I'm assuming that this, the upper left corner, or like that's how I defined it, is 0 for both. But then we go back from the screen coordinates back to normalized device coordinates. Yes. And what it's doing, as you can see here, it goes from like a width and height and transforms the left and right of width, or top and bottom, to from -1 to 1. This is like the that's why it's called normalized, right? So, and then from there we go back to the okay, this is the view matrix. First we apply the projection matrix, the inverse, which is transforming from NDC to what is it then? Before that is the view space, and from there we go back to world space. It's the next step. Yeah. So, okay. What did I actually? Okay. So we give it 0 and 0. Also, it doesn't do anything. With float, oh my god, I have these somewhere, and I think I called this orthographic, orthomatrix, and our point. So much stuff. Most a screen space. All right. Same for mouse B. Mouse B screen space. Okay. Let's see if this is actually correct. Mouse A screen space. Oops. Okay, this all of this is kind of janky, but dirty. But this is all code to be removed later. Must be, so I don't have I'm GUI, I'm GUI, not, I haven't set it up yet, so that's why I'm not able to do a proper debug window. But yeah, priorities must be, so this is the screen space. So now both the world space, right? Let's do this first. A screen world space, space mouse a world space. Okay, and then let's see translate it in Y direction and do a nice oh, sorry. I'm I'm new to this Twitch thingy, so I didn't realize someone posted in chat if I'm making a Raycaster. Yes, actually, I'm doing exactly that. For now, I'm just using it for collision detection because I'm planning to make just a tile-based like game, right? Where this player is running around and I don't want to hit the wall. So I'm using Raycasting to check if I hit the wall or not. And I haven't looked up actually any. I know there are tons of tutorials and implementations out there on the internet showing how this is done, right? And how Wolfenstein 3D did it. But I only know the theory behind it. I have never actually looked at any code, how it's really implemented. But I have a vague idea about the math. So I'm doing this. I hope I can do this tonight in the stream. And but I think it should be fine. It shouldn't be too hard, right? So, but like, even though I'm not planning to actually do rendering, like this typical Wolf 3D or 2.5D, some people call it, rendering, I'm not doing that. But even though, nevertheless, you could easily just do that, because what I'm doing, I will return the length eventually, how far the ray like goes until it hits a wall. So you could just use that and then and then just use it for drawing vertical lines depending on the length of how far the length went. So hope this answers your question. So now let's see, we have screen space. Oh, this is yeah, as you can see, great. Then these values make no sense at all. So let's try that again. Okay, there's garbage initially. Let's see, if I click here, right, in world space, it's, yeah, I clicked almost the upper left corner. It should be 0, 0. Screen space, yeah, looks fine. If I go a little bit up, oops, click again, because we're only checking the first point of the line. So up here, yeah, this is fine. This is 0 and this is -10, because we go like up in world space is actually minus, and yeah, to the left is minus. So the coordinate system is just defined like the y-axis is pointing downwards. For no obvious reason, actually. You can do that whatever you want, but yeah. It's just I wrote the rendering thing this way, so, and that's where we're at. So if I click the upper left corner almost there, then the screen space should be almost 0, 0. Yeah, it's not, but okay. Yeah, this seems, so we know this conversion from screen space coordinates to world space is actually working. Okay, now we can actually move on to the actual raycasting thing. Do cast some rays. So let's fire up Vulkan NVIDIA RTX extensions and use an RTX card to cast rays. No, just kidding. Not doing that. 1 second, I have to. Okay. Just taking care of personal stuff, like, even though it's pandemic time, there's still other stuff to do than sitting at home and programming stuff, unfortunately. So okay, so now the first thing actually I need to do is getting an idea about this situation, and I realize I have to kind of, whoops, what is that? Oh my god. I have to somehow rearrange my windows here so I can, on my second monitor, so I can actually see when someone writes into the chat. Okay. Okay, so let's start this thing. Okay, I haven't used that in a while, but I remember it to be quite good because it's not like, it doesn't have like super many features, and it just works. Okay, so the situation is this, maybe, I don't know, brush size 3. Okay, we have these grids, right? Or this grid rather. Boop, boop. And let's say the player position is just here right now. And the motion vector is maybe like this. Whoop. That's the direction the player wants to go. And so we have to check here this intersection, this intersection, this intersection, and this intersection. All right, and so like, how do we find actually this? Just let's say only take care of the vertical grid lines for now. So how do we actually find this first spot? So I know the X, because this, wait, let's do, can we do green? So the X component of this point here, whatever it is just from here to here, right? We know the player position in world space. And actually I have a function where I can say like, okay, this is maybe 300, 300 in world space, but in tile space, and each tile, right? Each tile we said is 32 by 32 units. And if the player world pos is at maybe 300, 300, as I just said, then we could transform this coordinate to a tile coordinate. And I have written a function. I think I have something like that. If not, then we just write that. But I think I have this. So and let's say, yeah. So this distance here is just like 32. If it's 32 tiles wide, right? Whoop. We just say this is the tile width minus the current player position, but like minus this thing, minus the distance from the left. So if, for example, 300, 300, right, in world position and in tile position, if we say the tile origin is 0, 0, and it goes to 32, oops, 32, 32, then the player position might be, I don't know, it looks like he's in the middle. Like for X, it might be 16. And for Y, I don't care. So that's the first thing we need to find. So for Y, so then we know X, like this is delta X, maybe delta X. Delta X. We have to go until we go here. But how much do we have to go up? And I think we can just maybe yet another color. Blue maybe. So delta Y. how do we find delta y? Well, we know this vector here. We call it direction d. I think I just can. So I'm not saying that I'm doing this 100% right, or like super efficient, but I do the first thing that just comes to my mind when I'm thinking about this the first time. But I guess we can just take the slope of d, so that means the slope m is like the y over dx. This is actually d and subscript y over dx, and then we have the slope, and then y should be delta x, like m times delta x. I hope I hope that's correct. Rusty math skills here, actually, I have to admit, especially if I do it on stream and I know someone would watch me, makes me not as comfortable, but I think this is fine. So let's do this. Make a new function, we call it, right? First of all, do we have, yeah, we have a function word space to tile space. Cool, that's good. So float, this will return like a line segment versus map, maybe. And we give it the position, the direction. We could just give it the directional vector and compute like normalized direction and length by ourselves. Whatever. Just give it the length. The length the player wants to walk. So the first thing, as I just said, is we want to know this position. If we go to from position in world space, we want to have it in tile space, like to pos tile space, world space to tile space. Yeah, this one, and we give it pos. And we assume the direction vector is normalized. So, and then we say we compute the slope m. Float m is dir y over dir x. All right. And then float y. First of all, float. The first thing we do is float x, like this, like how much x of this point, right? And as we said, this is 32 minus pos tile space dot x. I hope this works. Float y. Float y is, what do we say? X, just m times x. All right. Okay. Let's do a debug draw rect. X, y, maybe for line width, oops, and the color Okay. So we say, actually, yeah, this is unimportant right now, but we give it what we have to do now. Yeah, this is mouse a world space, right? The direction we have to compute, like to there is two sub mouse a mouse b world space float length is select2 length of direction, and then in the end we normalize it. So, and now we have direction and length. All right, let's see what happens. Failed, must return a value. Return 9999.9999. Whoopsie. Okay, so yeah, this square here, it should draw here. Something's not right with X and also with Y. Okay. Was this tile space, world space to tile space? We have that. We said 32 minus this. Oh, okay. Yeah, this is the delta X, right? The actual X is the current position plus the X. Okay, yeah, this is better. Whoops. Okay, so the X is correct. The Y is completely freaking out. Oh, well. Give it the X. Okay. Oh yeah, also, this is relative to the current position, right? So yeah, this Y is also just a dy actually. So we, yeah. So this gives me this m times dx gives me the delta y, right, as we just say here. This is actually delta y, should maybe delta y. And then of course we need to add it to the current player position, otherwise it's just somewhere like the reference point is wrong, right? This reference point might not be 0. So okay. Yeah, this looks a little bit awkward. I think we subtract a little bit because it's like the width and height of the rect, the debug rect is 4, right? I just want to offset it so it actually draws it exactly on the line. Okay, I hope you can see that. So yeah, this works. Awesome. Okay. So now comes the super hard question. What happens if we go from right to left? Doesn't work. Should we fix it now or fix it later? And first do the vertical. Let's do the vertical thing first. So for the vertical grid line, right? Sorry, we just did the vertical grid line. For the horizontal grid line, so just not to forget, this is vertical. First vertical intersection. First intersection with vertical grid line. Oops. Okay, and then we do the same for X, and this should be pretty obvious now. Like we did this for right now for the horizontal grid line. We need to do the same and just swap X and Y, I guess. So actually so this is for, let me get this pen thing. So this is first vertical intersection. All right, and then for the horizontal intersection, like here, whoop, whoop, first the first horizontal intersection should be then the M is actually dx over dy. So we have to swap it. It's like flipping the coordinate system, right? The coordinate system earlier was like this, whoop, whoop, x, y. And now we have to think in terms of like this, x, y, I guess. Like this is my intuition right now. And yeah, this is the M. And then delta x is M times delta y. Okay, I hope this works. Let's see. So float dy, so to the f minus postile times y, then the, so then we call this, actually this is the M for let's call it mx, or is this stupid? I don't know, reuse M. Let's call it mx. Float my stir.x, stir.y, float. Whew, getting kind of tired already, but it's late here. So now this is just pos y plus dy, right? And then we have float. Okay, now this is stupid. Because we have to, let's see, let's give these better names. Otherwise, this is getting really hairy. Let's call this first vertical x and first vertical y. Maybe this is a little bit more. Yeah, since as I said, it shouldn't be too hard to implement this, but as I'm doing this the first time, I want to kind of make sure I don't kind of trip over my own feet. First horizontal, and this is y. First horizontal x. this is the pos dot x plus my dot dy times dy. Okay. Yep. Looks good. First. Okay. Let's check it. Whoopsie. Okay. Yeah. Okay, this actually works. This is good. As you can see now, like we're getting, as soon as we get up here, this doesn't work anymore. Because as I said, like the y-axis is getting from top to bottom. So we're getting into a negative y here if we go up. So we have to take care of that. And this is the same problem we face with the x, with the vertical intersection. You see, like it's up, it's over there. It should be here. And I think we can fix this just by looking at, wait. If we look here, because this delta x is no longer true, right? If this becomes negative, like it goes in this direction. Let's draw this to be sure. Maybe just use a new one. Whoop. So this is not really square. But if we are here, and now let's again just care about the vertical intersection point. Maybe do it like this. The intersection point now is here, and what we are checking, we compute the distance from here to here, right? This is our delta x. But now the delta x is not really 32 minus the position. But if the direction is negative, the delta is this one. The delta axis becomes this. And it is exactly the position of the player, because remember, right, we start at the tile, in the tile space, the upper left corner has the coordinate 0, 0. The bottom right has 32 by 32, 32 in x and y. So this is the x, y. Yes, so this is wrong then. If we use it, we just 32 by 32 minus pos x gives us this. We just need pos x, which is exactly the distance from the first left vertical grid line of the player pos. Yes. Okay, makes sense. So we have to actually check where do we do this? So we say float the x, and we just keep it like that. And if dir.x is smaller than 0.0, then we say dx just becomes minus. I guess minus, because we say plus here, and we want to go from like here to here. We want to go, yeah, we have to subtract it. So it becomes minus pos tile space dot x, right? Now dx, we subtract the position and we get exactly to the next vertical grid line in x. Okay, let's see. Does this work? Okay. No. Drugs is negative. Is it? I don't see the mistake here, quite frankly. I really don't see it. Post space X. We go from pos X, which is in, right, this is in world space still. And we subtract the delta. Let's check it again. What exactly is happening here? Whoops, sorry. Okay, so obviously the horizontal grid line is working, but this is exactly the opposite now. Hello? Huh. Okay, sorry, just wanna make sure I'm not. Yeah, so. So I guess also. Yeah. Sorry, let's check again. So so this is really confusing. What? Also, this one is wrong now. Not seeing something. Mysterious. It should be pretty obvious what I'm doing wrong, but I just don't see it right now. Actually, in fact, exactly the other direction. If I do it like that. So this is not correct. Dx. I want to try something. And direction x is 1. Okay, no, I have to think again about this. What is going on here? So dx I think this x coordinate should be right. But it's really not. Okay, let's go here. Let's say whoop, whoop. So postile space. Okay. So the x is just minus 12 almost. Yes. Ah, okay. We have, although, first vertical x. Let's see, what should that be? We are here, so this is 32, 64, right? And it's becoming 32. Okay, I need a break. I don't know what's going on. Short break. So I was assuming that this is correct. So I'm pretty sure this is correct. I don't wanna kill this. So the first vertical x is the position of x. Plus dx, and this must be fine. Let's actually flip those because the mx is really related to the y. Guys, really don't know what to say here. It might be too late now, but I think this is really weird. Let's check this again. Okay. In this case, oh, wait. This shouldn't be negative, right? We draw from here to here. Or if I see this wrong. Again, there's a bug. So, oh yes. What are you? It's negative. Why on earth we passing the wrong direction? Oh my god. That's not good. Line segments. The direction is, oh, we go from ooh. You have to do it like that because this is the second point of the line. This is the first point, and this minus this gives us the direction from here to here, right? All right. All good. It's all good, baby. Okay, so this is fine. And this is also fine. Now this works with the vertical intersection line if the vector. Yeah. Okay, now we have to fix the other one, which should be exactly the same. So we say if direction y is smaller than 0, then please, Mr. Compiler, do this. Mr. CPU or Mrs. CPU. Compiler. All right. Done. Ship it. Okay. Yep. Okay. So this is good. So we can find the first intersections with vertical and horizontal grid lines. Let's drink some water. All right. Okay. Let's move on. So, boop. These comments should probably go away, but let's keep them for now, because why not? I'm just saying this because it's pretty obvious, right? There's a reason I have explicit names now for them, and now like this comments, they make them just comments to just obfuscate sometimes. All right. Next step. So now that we have found the first, let's focus on the vertical grid lines first again. We have found the first intersection with the nearest vertical grid line, right? So now we also want to find the next one, and 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 so on. So I guess I draw again a new picture, because otherwise I think it's a little getting too crowded here. So grid. This program needs a draw grid feature. Just kidding. This crop. Oh fuck! Sorry, my drawing tablet's making. I touched something there. I'm getting really good at this. See? Okay. So player is here. We go. Woo! So we have found this one. Actually, this is stupid if I do it like that. 1 second. Like, whoop. First intersection, we have this. This is done. Second intersection with vertical grid line. How do we find it? Well, the X is pretty easy, I guess, because this is just always 32, 32, 32. It's just the width of the tile. So this is just, so the delta X is 32. All right, so that's fine. What is Y? I don't know what color. So we are here now. We go there, right? Delta X. What is delta Y? So we can't use the initial delta Y, right? I guess. I don't know. Can we? No, we cannot. Of course not. This just looks, maybe if the player, right? is here. This goes like so. Then this delta y is pretty small compared to this delta y. Let me think a moment. See, this is interesting. Like the raycasting, just like I only know about raycasting, like what is being done, but not how. So, and I thought, oh, this is easy. But now this, I don't know. So if we isolate this part, right, we just have, okay, yeah, we can always use something with triangles where there's a rect. This is always good if you have a triangle and there's like this right angle. Is it called like that in English? Right angle? Like the delta x and delta y, they're perpendicular to each other, right? And this is a very cool property. Like if a triangle has that. So let's see, like if we have, this is the triangle, this is the vector, and these make the triangle. Then we don't know this. If we knew, then we could just skip all this and just go there. So we don't know this length. That's what we want to compute actually. We know this. This is fine. This, I don't know. Well, if we say we take this angle, you know what? You know what? I was always confused because there's a 32. If we just say this is 1, if we normalize this and say, hey, our just one tile it's just 1, right? It's just one step. Then we could just use like if we have like a unit circle, and this should actually x, y, and we have like a nice, oh shit. Actually make it like this, sorry. Whoop. This is like a squash ball. Yeah, almost fine. X, y, right? This is 1, this is -1, this is -1, and this is 1. And now if we have like this is our motion vector, like this thing is this thing here. And we say, yeah. And we say, here's our grid line. This is our tile, right? Maybe another color. Boop, 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 boop. This makes our tile. We just say it's 1 by 1. Then now we have this angle here. We still have this perpendicular sides. And I think so this part now, we can compute this through tangent, I think, right? Because this is the tangent, this thing here. And now I have to think about what was it? The tangent of an angle, like the tangent of this angle, is delta y, like this side over this side, delta x, or just x, yeah. So since x is 1, this becomes just delta y. And now so we don't know this angle, right? But this angle, this is quite easy, I guess. Yeah, this angle should be easy to compute, because we can, maybe this is not the correct way or the most mathematically easiest or the most, in the end, encode the most performant way to do that. But how we can, like, because we can just use the, I guess, the dot product between those two, between the direction vector and like the side, which is just 1 to the right, right? Like this delta x, actually we can make it a vector and say this is just a vector of 1, 0, right? It goes from here to here. So we say, what was the definition of the dot product? So if we say d dot x, like we make this x, is the cosine between those. So the cosine of phi times the length of d times the length of x, right? And now the cosine of this angle is just, sorry, wrong, d x over d dot x. All right. So now the direction vector in code is actually already normalized, right? We expect it to be normalized. We just say x is normalized because it's 1, 0. So this thing is 1. So it's just d dot x, all right? And then phi is the inverse cosine of d dot x. All right, cool, right? Now we can take this, whoop, plug it in here, and actually say, so then we say delta y, and just, I'm not sure if I'm actually saying, is this correct to say delta? Is it a delta or is it a correct, really the point? No, this is a delta, yeah. This is not the absolute value. This is just, this, I say delta because it's just a, how to say, it's, in the end, it's not our absolute world position value. That's why I say call it delta, right? So now this becomes, okay, this is, yeah, this is why I think that I saw this coming. So this is the tangent of phi, and phi is this. Whoops. Dx. Yeah. Ta-da! So, yeah, there we go. The cool thing is, the one cool thing is for x, like if we do the same, now this was for the next vertical intersection, for the next horizontal intersection. So we have a horizontal intersection. This was the first. We have this. I should use the pen. So for the next one, this one, we can use. So this was for next y component, or next delta y, I should say. Next delta y for vertical. And so next delta x for horizontal intersection. Everyone can read this, I bet. Delta x is the tangent of this thing d, and now the only thing we have to change is plug in this y. Done. Right, and this y vector, it's just a vector we make up. We just create on the fly. It's just 0, 1. All right. Cool. All of this makes sense on paper, to me at least. Some water. So the thing is, yeah, like I thought this would go faster, but it's always like that. You think you implement something, or you have something in your head, like, it should be fairly easy. I've read about this once. Should go fast. But if you actually stream it and want to think it through properly, it takes some time. And also, this should be fun, not stressful. So this is not a race. Also, the problem is it's so late here, but the thing is I cannot stream earlier. It's now 12 a.m. and so in the night, and I have a family, so that's why the earliest time I can stream is like 10:30 p.m. or something. Nothing to complain here, but it's just I'm getting tired also after a full day of family. All right. So here's the thing, right? I'm drinking water right now, but I bought some really good beer today at the supermarket, and like honestly, really good stuff. And I really want to like have a glass of beer now, but I know then probably it's not helping to get this done. Like maybe I'm not getting it done today, but I want to do this. This should be implemented now. Okay, so we implement this and then we drink some beer. Okay, let's jump back into the code. So next vertical intersection. So the next x, we just said we add 32, right, to our to the first vertical x. We just add. So we just say first. And now this is getting a little x. Now we don't add it here because now then the name is wrong and everything. Okay, let's say the y. We just we did all the math for that. So let's care about that. So we say float. We call it step y, okay? This delta x, we just say step y. And now we just have to use this thing here, cosine, equals, and we use the direction vector. We say vec2 dot arc there, and we say x, and this is just 1, 0, as we said, right? Oh, now I know what's happening here. I do accidentally hit my graphics tablet, and I can, like, there are some touch buttons or something, and I can scroll with that. Not cool. So that's it. I think, right? And now debug draw this. Let's say, yeah, draw drag, and we say first vertical x plus 32, because we just said we will make a variable for that later, but for now, just see if this assumption we have is correct. Oh, and also offset it a little bit, so the rectangle drawing is exactly surrounding the point. And then we do the first vertical y plus step y minus 2.0, and width for 0, 4.0, 3.0, red. Whoops. Okay. Is this working? Yeah. No. Okay, there's the same bug again. Actually, give it a different color. Let's say, yellow. All right. So here's the next intersection. So the x is correct, right? Just 32 more units to the further to the right. But the y, I mean, it's going up and down, but it's not exactly where it should be. So, so this, okay. I think I know what this is. We were making this assumption that this is 1 by 1, right? To just like not think about any, I just did this, or always do this, to not think about any like dimension or any coordinate system. So normalizing things is always making things or things to think about easier. I think, in my opinion. So, but what we now have to do, because we don't have 1 by 1 tiles, but they are 32 by 32 units, right? We actually have to multiply this by 32. Yeah, I think that should do it. Yeah, see, working. Don't look, don't look, don't look. It's nothing to see here. It's working, it's working. Just kidding. Yeah, now we have the problem again, and this is also easy to fix, right? We're always making the assumption that we are going in the positive y direction. But this is actually not the case. We should multiply with minus 32 if we go into the negative direction. Otherwise, we just, right, yeah. Otherwise, we just add a positive value. How do we do that? I think I do add something like int dir x is 1, but if we go negative, then direction x is actually -1. All right. Let's do the same already. I'm pretty sure already that's the word I'm looking for. I already can see that we kind of need this direction, like we want to have that probably for later as well, not only for this. Come on. Whoop. Okay. All right, so what we really want to do, let me think about that. So actually, maybe this is wrong. We don't want to multiply it with a negative direction, but we really want to just pass the correct vector. And our vector is just going like, it's not really about the y. It's maybe more so, let's see, let's and say dir x times, just not times, we just say dir x and 0, yeah. So if our vector, our direction vector, the thing here, is going to the left, it's negative. And then we don't have the situation where this direction vector is going in positive x, but in negative x. So we don't want to use 1, 0, but -1, 0, and that's what I just did there, right? So let's see what this gives us. Okay, this is still not correct. Actually, this is also not the problem we had. It is about the y. Okay, let's postpone this for a second. Let's go back to where we were. Okay, it's really about the yeah, it's about, of course, it's about the y direction. I'm still thinking. Let's see. Actually, if we take this vector and just mirror it, like we reflect it along the y-axis, then it goes like this. Then this angle is the same. So this should not be like phi prime. And those are the same then. So this should not actually influence it. So we do have to go and say dir y times, direction x. I'm stupid. Direction y, of course. Yeah. Yeah, of course. If we go, if we go here, we always, and this, say the coordinate system looks like this. Y, like x. Then we always add the step y. Remember delta y we just said, we called it step y here. We want to add this. But our current coordinate system actually looks like this, right? Y, x, then we want to subtract it. We really want to subtract it. We go in negative y. So that's why, haha, we need to multiply it whatever direction it is. Yes, so this is working. But of course not in the other direction. This is because the x is wrong. We just said here we add x, like 32. But actually what we want to do is multiply this with direction x, right? And if direction x is negative, we subtract. We go to the left. All right, but then this is wrong. So this means, let me see. Let me see. Ooh, this is getting a little. Yeah, but this works. So in this case, we need to actually flip the vector. If x is going negative, yeah, then we have to flip. We make it -1 0, not 0, not 1 0. Okay, there's a lot of multiplication and stuff. So maybe this could be, I don't know. Maybe this could be simplified, all this. But okay, let's go on. Let's say next horizontal intersection. So we call the step x, float x. I could copy paste this, but you know, whatever. 0 float 0 y. Oh, times 1. Great. Ooh, the graphics tablet is scrolling again. All right. Okay, I'm copy pasting this one. So now this becomes so this is the step now, right? Plus step x. Exactly, minus 2.0, again, to just make the drawing nicer, the rectangle drawing. First horizontal y. Oops, we could have used that. First horizontal y, and plus float 0y 32 minus 2.0. Let's give that maybe another color. All right, so first vertical intersection, horizontal, sorry, and the second one. All right, this works. Also the same works, and this also works. Okay, so that is good. Now what I want to do, and now we can, I think we can just reuse those. The good thing is we just compute this crazy thing once and then reuse it. because the cool thing now is, I guess, so let's do another drawing. So if we start here, we go away, and we only care again about the vertical intersections for now, right? 1 second, right? Okay, then the step Y we are always computed. Y. It's always the same, right? And the X is always the same. It's always 32, 32, 32. Why? This is the crazy like tangent cosine thing function we just wrote for the Y. Hey, hello. Like this one, right? And it's always the same. So that also tells us, I guess, right, that the length we go from, yeah, of course, the length from each vertical intersection to vertical intersection, whoop, 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 like this. It's always the same. And of course, that is true for the horizontal intersections as well. Then, so what is actually? Can I see the uptime in the stream? And thinking if I do this the next time, the like find all that, but I think we're always there. So let's have a glass of beer and then return. So I'll be back. 1 second. Beer pause. So. You notice the foam of the beer. Beer. Getting some beer. Be right back. So, okay. Let me tell you, this is so good. This is from a brewery like 60 kilometers away from where I live, and coming directly pretty cold out of the fridge. And it's a dark beer. The flavor, I don't know. It's really, I don't know the correct term in English for that, but I would call it spicy. But not spicy like a chili spice or something. Just very flavorful, very rich. So good. Okay, people. let's get rid of this. I want to have to the eraser, please. Ah, yeah. All right. Okay, let's do this. Let's implement all subsequent intersection points, right? Can I make this? All right. So actually, don't draw this. Don't draw this. And also don't draw this. And so for now we say like we want to have like maybe 4 or 5 intersections. And we just say we draw the first vertical x, first vertical y, 4, 0, 4, whoops, 4.0, okay. I prematurely deleted all these lines. 0 and 1, right? And then in the next, then we wanna kind of, we say, okay, now this may be stupid, but now vertical x, first vertical becomes just the next vertical x. And we just, so for the horizontal thing, sorry, for the vertical x, it's just always plus equal 32 left, right? We just go to the right or to the left, so that's why we have to say floater x, and the first vertical y is just a step, and the step already includes the direction. Maybe we should this also do here, then we don't have the multiplication here, but for now, okay, step y, all right? So let's see. Okay, this is working, right? It just draws the first 5 intersections with the vertical grid line. Draw this more pretty, right? And the same with the horizontal thing. I want to use different color actually than red. It's not that visible. Maybe just draw rect first for hostile horizontal x, first horizontal y, boom, and draw this maybe on 0, 1. Beautiful, first horizontal x plus equal. So the horizontal things, right, is just now becomes the step x, and first horizontal y is go. We just jump again from just we jump up or down, right? The times the 2f. All right. as you can see, all good. We have all the horizontal intersections, we have all the vertical intersections. Actually, this pink is absolutely stupid over this background. I don't know, maybe I just, 1 second, draw stuff. We just don't draw the map for now. Oops. All right, better. I hope this is visible on a stream. Okay, so now the thing is, right, whoops, if I draw my thing, maybe more like this, yeah, so we start here and go there, and we check at each intersection, vertical or horizontal, which is correct. But I think right now we don't know which one, because in each iteration of the loop, right, we check both. We check vertical and horizontal intersection. So it might be possible that we check first here and then we check here. But we actually want to check here, then here, then here, like depending on how far we get. Of course, we can do this, like, I guess, just compute both points and then compute the length and compare them and sort them. But this seems kind of, I don't know, stupid. I mean, what should I say, stupid? I mean, if it works, for an early implementation, that's always better than nothing, right? Just do it, whatever works, and then come back to it later. But I just got an itch that I don't want to do that, and I think that's just more work to type and think about in the end. So, but let's see if this is actually true. We say, 1 second, I use a buffer, maybe. Just a debug buffer where we like SAS printf and then into the buffer we say sorry, my keyboard. I have to switch my keyboard, right? And say the iteration, all right? Yeah, okay, this actually, no, this makes no sense. Because of course we check both at the same time. Let me think about it. So yeah, what we have to do, we compute what other color could I use? Maybe this. We compute both. Where's the pen here? So this is the length, and the initial length for the initial length for the first intersection is this, and this is not necessarily the same as the subsequent ones, right? And the first intersection, like the first length, those are like and here's the vertical intersection lines, like here, right? So the first vertical intersection, if we measure the length, this is longer than this. This means we have to check the vertical intersection first before the, did I say vertical for this one? Sorry, this is horizontal. And then the subsequent ones are longer actually. Like this. Like this. So we compute the first length. We compute the first length from here to here and from here to here, like from here to here and from here to here. That's the first thing we do. Yeah. And then we will see. So how do we do that? We have here the first intersection, and we compute the rect2, no float, init, how to call this? Init vertical length intersection distance. Okay, init vertical distance. Okay. And what is this? We go from the point we just computed, right? First, x, first vertical y, and this is a vector, and from pos, and then we need the length of that. Okay, this is where like I'm compiling C++, but I don't use any C++ actually, or like not really. So I could talk about this. This is just how this program evolved. It started in C, and then I kind of had to squeeze it. Like then I use C++ for various reasons then, but this is where operator overloading actually would become pretty handy. I just had a discussion with a friend today, or rather short talk about C++ 20, and as I don't follow C++ 20 actually, I don't know anything about it, but the one thing I really like about C++ is actually operator overloading when it comes to math. That makes the code so much easier to read and so much less typing. For other things, I have seen operator overloading crazy stuff where the intentions were good, but the outcome was, oh my god. Like it was so ambiguous what this operator in the end was actually doing, and you were expecting the one thing is doing something completely else, like doing your taxes instead of dividing something. I don't know, it's crazy, but okay. But for operator overloading, C++, pretty cool. Okay, we need the length. So see, this is just really not that nice to read, but whatever. Okay. We do this for that as well. Horizontal this vector, the length vector sub. We say first horizontal x first pause. All right. And actually what we do now, let me think. I just want to see if this is actually fine. Sorry, the scrolling. So if the init vertical distance is smaller than init horizontal distance, then we draw this. Else we draw the horizontal intersection, right? Right. Let's see. All right, see? Now we stay inside the boundary of the tile, which is correct. Because that's always the shortest distance from like in initial position, like this thing here to here. Yep. Okay, this is good. And now I see. So now we have to check at each iteration, like how far did we go? We go here, and it's shorter than from here, from here to here. It's much shorter than from here to here, right? So this is why we draw here first, which we just saw. And now for the subsequent points, we check again, or like we add this distance to the next vertical intersection. We add it to the initial distance to this, right? And then we check, is this distance longer than this distance? And it is. So we don't want to draw this first or check this first. This has the higher priority because this is shorter. And then after that, we add this distance, right, to this one. So it becomes this length, like this whole thing from start to end, which is longer than from here, like from here to here. So we draw this next, and so on and so on. I think this, yeah, this should be fine. This should work. So at each iteration actually here, we have to add like to the initial distance. So actually do this, right? This is still fine. Nothing wrong with that code. let's see if we can do this length stuff. So not only we have computed the length to the first vertical intersection and the length to the first horizontal intersection, right? And now we want to compute the subsequent intersections for horizontal and vertical grid lines. And as I said earlier, I believe they, not only I believe, it is true that they all are the same length. Like this, it's like this, it's like this. And it doesn't look like it, but those two, whoops, those two segments have the same length as well. So that means first intersection, the next intersection. So now we have to find the length of the next intersection vector, which is just, I believe, float how should I call this? Next vert something like that, and then select to length. Actually, we don't have to use the sub, we just plug it in, right? Yes. We just use this x and this y for the components, and then we get this length, I guess. Let's see. So that would be vertical, first vertical x. So let's see, is this just 32 and then step y? I guess so. Let's see if this actually works. Float next horizontal length. And that's just step x and 32. All right, Lord MZTE. Have a good night. Take care. Thanks for dropping by. All right. All right, yeah, that should work. And then we say, like, for each iteration, so we just say the init vertical distance. So this distance, 1, right, is shorter than this one. What we do is add the next vertical length or distance, like call it distance. Oh no, it is actually a length in this case, right? This naming stuff is the most difficult thing in programming. To make programs without comments that you can just read without guessing what is what. Okay, but what we do now, we say the init, we add the next vertical, right? So this was the init distance, next distance. We add it together, so it becomes this length. And this one is larger now, it's not smaller than the init horizontal length, right? From here to here with the horizontal grid line. That means in the next iteration, this branch is taken. And same here. All right. And now, yeah, obviously init horizontal this is not initial anymore. It's becoming actually longer and longer. First goes for first vertical X, first vertical Y, first horizontal Y, first, but we can rename these later. But now, let's see if this actually does the right thing by drawing. So what do? We say just printing the iteration of the number of the loop, printing I, or drawing I rather, draw text, and we say first vertical X is 2 F, first vertical Y minus 2 point F or 4 point F, 4 point F. What am I doing? Scale 1 point F. Actually, I like this. Okay. All right. Let's see. Sorry, one thing. What is he complaining about? Switch statement contains no case default labels. Yeah, that's true. All right. Yeah, we just commented out earlier. We don't draw the tiles so we can see the grid lines better. That's okay. Okay, this is correct, right? Let's see. So here now we can see it's 4, it's 4, it's 4. Now it's crossing the 3 and we go here first. Yep. All good, all good. All good. So now we actually checking in the correct order, right? This is good. Works in all directions, it seems. Fuck. Sorry. Right. Yep. All right. Okay, cool. So the numbers are pretty big. Make it 0.5 maybe. So now we also, what I also want to do, of course, is I want to get, so to explain this, maybe we start the program again. So if my line goes like this, I also want to, like, we have an intersection point here, right? I want to know what tile in the map it is. It's this tile. When I hit this intersection, it's this tile. When I hit this intersection, it's this tile, and this tile, right? So maybe we just do another debug draw, and to draw all the tiles that are being tested, actually. So I also think I've once written a function that gives me, like, for a vert coordinate, that gives me, oh yeah, of course. No, that gives me actually a tile number. World space to tile numbers. Well, it's a vec2 with integers. Okay, so now what we can do. So we say vec2i, and we say test tile is equal to test tile numbers. Yeah, let's say test tile chords. Is world space to tile numbers, right? And we give it the initial vector or position or current position we're in, right? And now thinking how I do this the smartest way. So we go here, right? From here to here. I hope this cursor is actually, the cursor is visible in the stream. I think so. So we go from here to here, and then we hit this tile. Then we go here, which is, so we go from this tile to this. Then let's do another color. Go from here to here, +1 in X. Then we hit the vertical intersection line. So we go from here to here. That's like, because our coordinate system is like this, right? X, Y, we go -1 in Y direction. The next intersection is this one. So we go right again, +1. Next intersection is this here, this tile. So we go right again, +1. Then this intersection, -1. This intersection, +1. So what is really happening with each intersection? We step up a tile, or we step to the right one tile, right? So with a vertical intersection line, we go either, depending on the direction vector, we go either left or right, or with the horizontal intersection, we go either up or down. So let's see, that would mean our test tile chords. So we just hit a vertical intersection line here, because this is one, right? Vertical intersection line. So we go to left or right one tile, plus equal 1. Dot X, right? Yeah, but we also have to do -1. Oh, we have our dir Y and direction X already established, so we use that. And it's an integer, how convenient, dir X. So I knew we need this, again, for multiple things. Sometimes you have like this intuition. Test tile chords dot y plus equals dir y. Whoops. All right. Okay. Now, with each iteration, we have our tile, right? The test tile, I hope. And we just debug draw this again. Draw rect, and we say test tile chords dot x, and we just do this dirty, say times 32, right? because each tile is 32 wide and in height. Test tile chords.y times 32. And then we say width 32 by 32 and width 0, and we make a nice yellow color. Come on, 0. All right. Let's see what's happening. Whoops. Oh, there was some initial stuff that was quite ugly. That's because our, let me fix this. This is annoying. 1 second, 1 second. Where do we do the conversion here? Whatever. Okay, screw it. You know what? We only do this when the mouse state is equal mouse state drag, right? Or mouse state is equal to ms drag and released. So only when we actually have a line, we do all this stuff. Length. Problem is the initial state is released, right? Oh no, okay, screw it. Whatever, for now. I want to focus on the real problem right now. Okay, so, okay. So as soon as we step down, is this correct? Go here. Let's see. Let's make a new. Wow. So, this is annoying. I don't want to draw it when I just clicked once. I only want to do this when I actually have a line. I've made a line. Okay, yeah, but too late. I'll do that later. All right, so this is correct. Boop, 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 boop. This tile. Then dum. Seems okay. Now we go down there and now down here, right? So it seems this is working. So we find all the tiles we actually intersection, also in the right order as the numbers are showing. All right. Okay. Okay, it seems to work. That's great. Phew. Okay, I think I'll stop the stream for today. It's quite late. It's 1:30 a.m. and I'll continue there the next time. So the next thing we want to do is actually we do an iteration of 5 hit points, right? But actually what we want to do is we want to stop whenever we hit the wall. So that's the first thing. So at each iteration, we just have to check if we hit a wall, and if so, then we return the length we can walk to this wall tile and stop the loop. And maybe don't use a for loop, but a while loop to actually only do this as long our line is, right? And not some arbitrary integer number we iterate over. Yeah. All right. So the little mask guy says, thank you for watching. See you in the next one. And then hopefully use the raycasting to actually let mask guy bounce against some walls. And yeah, stay healthy. Have a good one. And see you next time. I think maybe next Wednesday. I plan to do this weekly, but maybe also earlier. Depends. All right. Good night, folks.